Hello, I'm James Wilby. This is an EFIS Differences brief based on the Aspen EFD1000 as fitted in Golf Oscar November Oscar Alpha for VMC flights. This brief is not a substitute for reading the operating manual or receiving differences training in the aircraft from a suitable FI or CRI. The aim of this EFIS Differences training is to ensure an understanding of how the system operates and the key differences from using traditional analogue instruments. The objective of this presentation is to provide sufficient background information alongside reading the operating manual to brief you for an EFIS Differences training flight. So what is EFIS? EFIS stands for Electronic Flight Instrument System, and it's a flight instrument display system in which the display technology is based on electronics rather than mechanical operations. A typical EFIS system comprises of a primary flight display, known as a PFD, which includes the electronic attitude indicator, and an electronic horizon situation indicator, an EHSI, which also holds the navigation display. These are either shown as two separate displays or integrated onto one screen. Although EFIS uses common colours and layouts, operations and features will vary between manufacturers and models, so it's always important to refer to the correct operating manual and seek familiarisation. EFIS systems use an air data computer. An air data computer utilises the same instrument input as traditional analogue gauges, primarily the pitot and the static inputs. Therefore, normal checks, including the operation of the pitot heater, are required before flying. And pitot heat should be applied in applicable conditions. You can see on the right side how the pitot static tubes enter the EFD. The air data computer calculates the difference between the total pressure and the static pressure to generate the information necessary to display airspeed, for instance, on the PFD. There is also a remote sensor module, RSM, mounted on the top of the aircraft, which contains the other sensors required by the ADC. You should check for the security and the condition of the RSM before flying the plane. EFIS systems also rely on an attitude and heading reference system, shortened to AHRS. Electronic flight displays have replaced the free spinning gyros with solid-state laser versions, and these are capable of flying any attitude without the risk of tumbling. This capability is a result of the development of something known as the AHRS, and it's this which generates the pitch and bank information which is shown on the display. The heading information is derived from a magnetometer. This, as you can see in the side diagrams there, senses the Earth's lines of magnetic flux. The information is processed and displayed on the HSI and the PFD to generate the heading. The magnetic heading information is also pre-corrected from the Earth's variation using an inbuilt database. RPA-28R Golf Oscar November Oscar Alpha is fitted with an Aspen EFD1000 Pro. This is a single device that can replace the standard 6-pack. With the masters on, there is a separate switch to the right of the Garmin stack to turn off the Aspen, close to the radio master on and off switch. This can be tricky to see from the left-hand seat. Do not start taxiing while the system is initializing. It must display the attitude indicator before you start moving. Likewise, as you turn off the radio master, the PFD should be powered down before shutting the engine down as part of the shutdown checks. The EFD1000 obtains its primary navigation information from the Garmin's. The EFD1000 does have a backup GPS, which is limited for VFR use only. Golf Oscar November Oscar Alpha also retains a vacuum AI and an electric gyro coordinator, so you'll hear these gyros spinning up and need to include in your checks a checker for such an indicator. The HSI gets its directional information from the magnetometer discussed earlier, so there's no need to align the compass, and there's a database that holds the magnetic variation. During en route checks, reader checks, always cross-reference to other instruments, such as the compass, the IAS, the altimeter, to ensure the PFD is displaying the correct displays. One thing to note is the EFD is in knots, whereas the ASI outer gauge, most placards, and the Pilot Operating Handbook are all in MPH. In terms of basic layout, the screen is split in two, with the top half showing the attitude information and the bottom showing the navigation display, or most often the HSI. Along the centre, however, is a very useful data bar, which includes showing the ground speed, the outside air temperature, and the wind direction and wind speed. It also shows the true airspeed. The EFD1000 is operated using keys down the right hand side. These keys, particularly the bottom section here, take the option that is displayed currently on the screen. So this may change depending on what menu you are in. There are two knobs at the bottom of the screen. These have a click action to make changes and turn right or left to make selections. The knobs operate what is operating is what is currently above them. It needs to be in magenta to be editable. For example, to change the heading, you would click it once, it would turn magenta, then you can turn the knob to move the heading bug, or hold it in for 3 seconds to set the heading bug to the current heading. The 3 buttons along the bottom indicate various navigation sources. The center button is the primary navigation source and therefore reflects the course direction indicator, the CDI. And that's shown in green on this, even if it is GPS, unlike the Garmin's that normally show magenta for GPS. So in this case here, GPS 1 is taking the GPS source from the top Garmin, GPS 2 would be the bottom Garmin, and it's displaying it as a CDI lever here. It's auto-coursed, so it's pointing in the correct direction. Above the left button, you can see VOR1 and a single line. That's reflected on the heading, the HSI, by this blue line indicating a bearing to that VOR. In this situation here, I've actually got GPS 2. This would be a second GPS box showing it with a double arrow, and you can see that as a bearing to it there. Point of note on Oscar Alpha, the GPSs cross-feed between themselves in both directions, so the GPS source should be the same unless the cross-feed's been turned off. Just to reiterate, the left knob controls things on the left side of the Aspen, and the right control knob changes things on the right side, and the active field will be magenta. So in this case here, you can see HDG heading is magenta, and therefore this knob here will change the heading value and move the bug. Just as a point of interest, EFIS instruments are laid out in a similar format to the traditional 6-pack, perhaps except the turn coordinator. So you can see here that speed is indicated on the left, altitude on the right, vertical speed on the bottom right, AI in the center here, in the top center, and the direction in the bottom part here. Worth of note is the turn indicator is shown at the top of the HSI by this white mark you can just see indicating there. The standard tick mark here, just to the left and to the right, that shows a standard rate 1 turn. So the white arc will come out to that line. I recommend doing the differences training to perform a rate 1 turn so you can see how that is reflected on the HSI, top of the HSI screen there. The inclinometer, the ball, that's indicated by a white line under the AI indicator at the top there. More on that in a second. So as you can see, the upper section of the PFD is the primary instrument to control the attitude of the aircraft. Each line on the attitude is showing 2.5 degrees of pitch. This compares to an analog AI where each line is 5 degrees. The attitude will show the attitude of the plane. So it may show a pitch up and down in straight and level flight, depending on speed or perhaps flap configuration. This is non-pilot adjustable, and that's common across all EFIS devices. Partly this is because there are no parallax errors with EFIS devices. The top half also shows the speed, as we saw on the previous screen on the left, the altitude on the right. It also shows the slip skid indication, which we normally would refer to as the bore. You can see that in this picture here, that the slip indication is indicated, the balance, if you like, by the white rectangle under this center pointer. The white rectangle width is equivalent of one bore width. So if the rectangle was all the way out, then the bore would be all the way outside one of the traditional lines, markers you would see on an inclinometer. So in this case here, you would need to step on the rectangle, apply some right rudder to bring the plane back into balance. So remember, step on the rectangle rather than step on the bore. The barrow pressure, which can on the altimeter, that is controlled by pressing the lowest button on the right hand side. It will have the word barrow next to it, and then using the right knob, which above it will have the current barometric pressure in magenta, and turn that left or right to set. There is a button labelled TPS, which can be active. That will turn the airspeed ribbon on and off to give a larger AI. I recommend you don't turn it off. If it is turned off, then press the TPS button to turn it back on. The top half also shows navigation information, albeit abbreviated, but it shows the magnetic heading. It also shows the course deviation information, the CDI, using a series of diamonds, as you can see down the bottom here. It also has that useful information as we discussed around true airspeed and ground speed, and the outside air temperature and pressure density to help with performance planning. The horizontal and vertical course deviation, as I said, is shown by a green diamond. And you can see here we've been flying slightly to the left to intercept the course, or this one is if you're doing an ILS, it's actually spot on. A hollow diamond indicates the deviation is out of range. The lower section works in a very similar way to a standard HSI. So this replaces the DI and the CDI you may find on traditional analog setups. If you've not used an HSI before, I suggest you get a briefing from your flight instructor if required. The current heading for the DI is always shown at the top there, numerically as well as under this pointer, so it's very easy to find. This HSI, electronic HSI, has many advantages over a mechanical HSI, one of which is being able to display more than one nav source. The CDI source is always here in the center, so you need to select that on the Garmin. In this case here, we would have selected GPS on the Garmin and have a route, a flight plan, or a direct to set. If selecting it on the Garmin does not bring the same source in here, it can be changed using the center button. The outer buttons show bearings too. So in this case here, I have a VOR, and there's a single line indicated here. So this single line here is showing the bearing to that VOR. This one here is always a double line, as you can see. Just to note again, the GPS, unlike the Garmin, is shown in green. The main CDI is always green, regardless of it being a GPS or it being a radio, a VLOC. The top line shows the course, so that's the course of the CDI here, 164 in this case. The current heading, the heading bug, so you see the heading bug there, and you can see that's set on 119. And heading bug can be changed by clicking the right button once, this will go magenta, and turning the right knob appropriately. Holding in for 3 seconds will put the heading bug to the current direction, the current heading. By default, the auto course is enabled on the EFD1000, which means it auto slew the course pointer in GPS mode, which most of the time will make sense. I can only imagine you would not auto course if you were having to use GPS to help find your position. And if it's on or off, the option can be found using the menu. The inverted A in front of this CRS is a reminder it's on auto course. With a VLOC source, so changing the center here to a VOR, for example, use the left knob to move this course to point the CDI pointer to the appropriate heading if you want to track it. Holding the knob in for 3 seconds will automatically select the reciprocal heading though, which is really useful with a 2 direction. You'll notice, well, just slightly there, you can see under the heading bug a small blue diamond. That is our ground track. I'll mention that again shortly, but pulling the ground track onto the course pointer means you are following the track over the ground, which will take you to that course, take you along that course accurately. If you see a hollow deviation bar, it means it's off scale. When switching between sources, be aware the CDI needle will stay in the last position. So if you're switching between GPS and VLOC, you will need to readjust the CDI if you're following you want to follow a particular course. Looking further at the lower section on the navigation part of the EFD, you can see clearer in this screenshot the blue diamond, which indicates the current track over the ground. When the track diamond is aligned with the course pointer, the aircraft is tracking accurately on or parallel to its desired track. To align the track diamond with the course pointer, turn away from the direction. Think of it as pulling the track diamond towards the course pointer. That becomes very useful when you say tracking something like a VOR, or you want to accommodate for wind conditions which were different to those predicted on the ground. The lower section of the navigation shows the VSI. It shows a trend vector with white bars up or down when the vertical airspeed exceeds plus or minus 100 feet per minute. Always at the top is a numerical value, clearly stating how many feet per minute the plane is ascending or descending. One thing which is different when flying with an EFIS over a vacuum-powered instrument is you don't suffer the lag, particularly in the VSI, which you may remember your flight instructor showing you at some point can show you're climbing when you're actually descending. So you can trust the instruments are going to be up to date. That goes the same for the airspeed as well, but it's going to not suffer the lag that you have on the vacuum or the analog instruments. The rate of turn indicator we talked about earlier on is shown at the top of the HSI, and you can see the thick mark here and here. These show a rate 1 turn, so that's calculated based on the true airspeed. There's a thinner mark just inside which shows a half rate turn. The white arc will be annotated by an arrow, as in this example, when the turn exceeds 6 degrees per second. So it's going to be something like a 30-degree bank turn at that point, as in this example. So I would suggest when you're doing your differences training or familiarization training with your flying instructor, you perform a rate 1 turn, which you can use in an Oscar Alpha. You can use the normal turn in the electronic turn indicator and see how that appears on this display. Just one thing to note, it's a better place to put it than ever. If the GPS 1 or the GPS indication at the bottom of the HSI has a red cross through it, this likely means you actually don't have a flight plan or a direct to set. It's not that there's a fault with the GPS, but the GPS relies on something coming from the Garmin to say, where do you want to go? So typically when you initially start taxiing, you'll notice a red cross through that if you haven't got a flight plan on there. The lower section can also show a base map underneath the HSI, and this comes from the GPS source, for example, the Garmin's in Oscar Alpha. There is a map button which can be used to cycle through 4 levels of detail, and a range button a little bit further up, not on this cutout here, can be used to change the scale. The nav section can also be put into a 100-degree partial heading arc mode. In this case here, the aircraft symbol is shown at the bottom of the screen and the current heading is always orientated up. This is a typical display and useful when flying en route because it provides an extended forward view. The arc mode can be shown in an HSI format or a non-rotating CDI indicator, which can be selected from the menu if needed. In arc mode, it's just worth noting that the VSI is only shown numerically. You no longer have the white tape going up and down. Just looking at the to and from indicators, you can see here this is a to indication as the arrow is pointing in the same direction as the CDI. Maybe I'll run better on this one here. If there is a from indication, you'll note here that the arrow is pointing away from the course direction indicator. It's also indicated at the bottom of the screen here with a more clear word from or to and a solid diamond with its in scale. So these two displays are showing the same things. Again, as a point to note, the flight plans between the two Garmin's in Oscar Alpha cross-feed in both directions. Another useful feature over traditional analog displays is the ability to add in various bugs. One of these is the altitude bug. This becomes live once you're flying. Press the right button until Alt appears above it, then turn the right knob to set the bug. The faster you turn it, the bigger the jumps the bug will make. And you can set an altitude, say the altitude you want to reach today. The altitude will be highlighted in yellow and provide a warning within 200 foot or 15 seconds. So you'll hear a tune over your headset and it will flash yellow. Once at, say, 8,500 feet, there will be a warning if the altitude deviates by more than 200 feet from this. You can also set, very usefully, a minimum altitude. Press the button on the right next to the word min, and this is how all these buttons work, and use the right knob to select the minimum altitude. Again, it will flash on the screen minimums and beep through the headset as a warning. This might be useful, for example, if you're cleared across Brize Norton at no lower than 2,000 feet. An airspeed bug can also be set using the left button until IAS is displayed. So tap the button, it will say IAS, and you can set a speed bug. There is no visual order or warning for this one though. In Golf Oscar Alpha, the roll axis autopilot is linked to the Aspen in heading mode. So what this means is you need to set the autopilot in the HDG mode. So that's the center selection on the turn on the dial. Then the autopilot will follow the heading bug. The autopilot can also follow a flight plan or GPS track via the Aspen. To do this, on the GPS, choose GPS as a CDI source. You need to have a flight plan or direct to set, and then ensure the CDI source on the GPS is on the Aspen too. Then, using the right button on the right next to the letters GPSS, GPS steer, select that mode leave the autopilot in heading mode, and then GPS roll steering will take over. So if you just have a simple direct 2 in, the autopilot will now follow that line on the GPS, for a better words. If you have a flight plan put in, GPS steering will actually anticipate the turn onto the next leg of the flight plan, and you can see that what it will do in the diagram at the bottom there. Press the GPSS key again to return back to following the heading bug on the autopilot. When, just as a point of note, if nav is selected on the autopilot, it will follow the CDI source from the primary Garmin, not from the Aspen. The altitude hold autopilot is independent in the Aspen. I suggest trying this out with a flying instructor as part of your differences training. It's very effective. The Aspen has a backlight, so it's very visible even in bright sunshine, and it's set automatically using light sensors. There may be times when you want to adjust this, for example at night or in very, very strong sunshine. To adjust this manually, press the menu button, which will be one of the right-hand soft keys, and use the left button to select the option BRT adjust. Then a little scale comes up, as you can see in the bottom here. Move it from auto, tap the button, move it from auto to adjust. In auto mode, the maximum is actually 70%, so if you find the screen too dim, you can adjust it. The Aspen also has a backup battery in case of power loss. The battery lasts approximately 30 minutes. When the battery is on, the screen though has a maximum brightness of 45%, and you will get a warning come up on the screen. In an unusual circumstance with power issues, you can also go in the menu and you can force the Aspen to run off the battery. Not sure, if required, if you had other power issues and you wanted to do that, or maybe save the battery on the plane for other use. So it's worth bearing in mind you do have those options. The using the menu button as well, if you rotate the rate knob till you find the bat option, you can check how much battery charge there is remaining. It should be 100% as long as somebody hasn't been using the battery. As part of the freezer check en route, you should always ensure there's no flags and cross-check with other instruments when using the Aspen. Unlike a traditional vacuum system, where it may not be immediately obvious if there's a fault such as a blocked pitot tube, the ADS will detect abnormal data relatively fast. It will indicate this on the screen with a red cross flag across whatever has failed, in part or whole. Recycle, turn on and turn off, is one option first of all. To turn the Aspen off, you need to hold down the key marked REV at the top right for 10 seconds. Press it again to start. Turn on the pitot heater and maybe use the alt static if required. Cross-ref for other instruments as needed. And as stated earlier on, the Aspen has its own non-certified GPS if one of the Garmin's fails, and it should be used for VFR only. Above all, remain VMC or get into VMC, aviate, navigate, communicate, then troubleshoot the electronics, and keep a good lookout outside. Just a couple of examples you may want to discuss or use as a better understanding of the system. You can see here the barrow is set to 1009. That's here. To change that barrow, I would click this button here next to the word barrow and use the knob, which is just cut off here, to turn it. Note the V speed on the tape. So you've got VA, VFE, VY just appearing there. In this case here, the bearing is set to GPS 1, which is on this top nav here, which happens to be Wellsbourne. So you see the bearing there. It's the blue line, indicated with a single blue line here. And that feels sort of logically correct. Yeah, it's slightly off our current heading. V, in this case here, I have 116.4 set, so Daventry. VOR, which you can see here on the Garmin. And again, it's showing here a bearing from, so it's showing because you've got the arrow pointing the opposite way to the CDI. So it's showing I'm in a westerly direction from DTY. If I want to make this 0.2, I turn the knob under the course heading here, tap it and turn it, or if I hold it in for 3 seconds, this will point to Daventry with a 2 indication, and that's really useful. So a couple other things on this screen here. You can see here I'm still set towards Daventry VOR, and you can see this time I'm very slightly off my intended CDI, my intended course, and that's indicated also by the green diamond. So you can see that's about the same width away from that center mark. You can see actually a little bit of the base maps here as well. It's difficult to see on this screen what they are. This time I've set the bearing to GPS 1 again. You can see actually it has a reminder here, it's EFIS above it. And again, about 3035 feels logical, feels correct. I mean, you can see here as well, we've got our true indicated airspeed. I've got our ground speed, 148 knots. Outside air temperature, 5 degrees, and the wind being shown here as well, 277, 18 knots. You can see very clearly as well, this is a 2 indication because I have the center arrow pointing in the same direction as the CDI. The scale of the maps down here, 20 nautical miles, and this indicator underneath is the level of detail shown on the map. So if you need to change that, you can. This example shows the HSI in arc mode. So you can see if you're flying en route, it makes it a sort of larger screen to look at. You can see it's still set for VLOC 1, so it's still pointing at Daventry, indicated with this green arrow over here. You can see the detail about that here as well. You can see that Daventry is 70 degrees, 07 degrees. It's 40 miles away, and it would take me 18 minutes to get there. So some really useful information in the screen here. This is the GPSS option we talked about earlier on. So if I change this to GPS, if I select GPS here, I'm using the CDI button, this says GPS 1 under here. If I press the GPSS mode and the autopilot's on heading mode, it will follow that magenta line for me. Again, you can see there's some wind indicated here and the ground speed 146. There's an altitude bug set as well at 4040. So as I approach that, that will start flashing yellow and give me a warning. You can also see here the REV button just behind here. So if you do need to power the device off in flight, you need to hold that down for 10 seconds. Worth a note, when you power off or if there is a loss of power to the Aspen when you are flying, you have only around 10 seconds to press any key to keep it alive. And just one last example here, showing this time GPS selected on the CDI here and the auto course pointing that GPS at 069, which you can see here as well. So if I was on the GPS mode now, it would quite happily follow that magenta line for me as long as the autopilot is also on heading. Again, you can see some detail on the map underneath there. The heading bug has this blue line coming out of it just to make it easy to see. That's all that's showing there. And the heading bug is set at 50 degrees. Notice actually it says Alt here. So it's currently in the mode where if I tap that, it will go magenta and I can set the altitude bug. As I said earlier on, if this powers down in flight, if you lose the master or when you're turning it off, if you need to keep it alive, press any button relatively quickly and it will run on battery. In terms of threats and errors to manage, some of these will be when you're learning and some of these will be ongoing. A particular threat is spending too long looking inside the cockpit, missing other traffic or becoming unorientated. So learn as much as you can on the ground. And when using the device, change one or two things at once and look out, then change the next thing. Don't fixate on tidying in an entire frequency or changing all the settings without doing one or two at a time and then looking out to make sure you know where you are and you're looking out for other traffic. Train over an anchor point when you are learning to ensure you don't lose your position and go into controlled airspace, for example. Train with a flight instructor, a CRI or a safety pilot who can look out particularly while you are learning and studying how to use the Aspen. Use Pilot Aware if available. If you do inadvertently fly into clouds, IMC weather, it's important to learn how to do a 180-degree turn with these instruments or a time turn. Level turns at certain speeds may show a 2.5 pitch up attitude. This will vary on the speed the plane is flying at or the configuration with flaps. So you need to learn the correct attitude for the plane. So look at that when you're flying straight in level and learn what that looks like. Have a think about what else you might need to consider. In terms of errors, you could have the incorrect settings. So the baro, the screen brightness might be too dark. You could be on GPS rather than VLOC, or you could switch between the two and not realign the CDI. So cross-check with other instruments and known datums. Set the baro on the ground with the QNH and ensure that it's reading at Wellesbourne somewhere around 153 feet. And when flying, check it against other devices. Entry of controlled airspace, again, could be set easily by having the wrong baro, particularly if you're getting up towards flight levels. So learn how to read the altitude, but make use of the bugs so that you don't go flying into something at 5,000 feet. You can set a bug at maybe 4,500 feet, give yourself that margin of error, and the system allow it to warn you when you go 200 feet out. And of course, there could be the misunderstanding of navigation information. So make use of moving maps, charts, confirm with ground references, and ensure that if you're following a particular direction, you are following the correct, if it's to, if it's from, and it feels correct as well as looks correct. And have a consider any other errors you might make. Thank you for sticking with me during this presentation. For further reading, the Aspen manual should be read by anyone who is going to fly the Arrow and use the Aspen. It's relatively easy to read. It is quite long, but it's got lots of good examples in there. You can obviously refer to EFIS in general in the latest Air Pilots Manuals and Poolies. The the FAA published their flight instruments guide online. It's pretty good, nice, easy to read. And if you're interested in instrument flying, they do a specific handbook on how to fly instruments using EFIS. So there's some good sources of information out there. So thank you very much. I hope you enjoy learning more about the Aspen in the air and your differences training, and enjoy flying the Arrow. Thank you.